Okay, so today I'm going to be doing a review on this. This is probably the worst power supply you can buy off eBay. I want it for $35 and I don't expect there to be much inside it. Let's open the box. Surprisingly low amount of Chinglish in this manual. In the box we get the power supply unit itself, some very cheap multimeter test leads, and this combination test lead that they did have a picture of on the eBay auction. Basically it's got some standard banana plugs on the end, a junction box, which then goes to a variety of alligator clip, these pin clips, and even a USB socket. These are all I'm not sure if they're meant to be. Like so. Could just be faulty. Anyway, let's take the sucker apart. Alright, so here we have the power supply. I'm just gonna tear it apart. Here we have the insides. There's a 7805 5-volt voltage reg there, presumably to power the logic. Main wires for the transistor are just soldered on the ends. No heat shrink, no nothing. I have a grounding wire here though. It's always good. There's also a fuse at the back. Can't read the rating off that right now. Yeah, there's not much inside this little sucker. Apparently it's got some sort of, this is designed for people who want to repair their own mobile phones at home. And it's got an RF detector, so we'll be checking that out. The main transistor is a 2N3055. Pretty old, pretty crusty model, but hey. So I had a bit of a poke around off camera, and I found this little decoupling cap here. Assume it's meant to be soldered to this lug here, and well, there's a blob of solder here, but clearly it's either been soldered properly or not at all, and it's come off. So when you get this cheap stuff from China, make sure you check for these things. So all the mains wiring stuff seems to be heat shrunk, so that's a good sign. I checked for shorts, and if the outer case is grounded, then it is. So next step, I'm going to plug this in. Alright, so I've now got the power supply hooked up with the supplied cable that came with it to my HP 3478A multimeter. We're going to power it up and see what happens. Alright, so let's increase the voltage. Oh, there we go. See if we can get it to 1 volt. It's looks like it's not that unstable. And it looks like you can tweak it down to whatever voltage you want, just really carefully. See if we can get it to 1 volt. Nope, too far. There you go, that's pretty close. Not bad. Right, let's see how high it goes. Yeah, max voltage was claimed at 15 volts, 15.5, and yeah, the 3-digit little display here seems to track quite well. Bring it down to 10. Yeah, yeah, 10 volts. So I don't think that's too terrible. We'll try 5. There we go. This switch at the front, all this switch does is switch the output from this terminal to this terminal. Presumably so you can have a dedicated multimeter set up to measure the output or something. Hang on, it doesn't actually do anything. I'm not sure what this button does. Is it current limit? Maybe it's the current limit. I doubt it though. Hang on, let's put a load on it. So just quickly, I figured out what this switch does. Duh, it was obvious once you actually read the front panel. This is actually a way you can test the voltage that you input into the power supply. So I've just got a LiPo battery here, and if I flick this over to test voltage, as it says on the front panel, and apply a voltage to the front panel terminal, then it still doesn't work because fuck. You know what? I don't know. I have no idea what the purpose of this is. There might be some kind of wire loose inside that I missed. But this terminal, I don't know. Anyway, I've now got a light bulb, car blinker bulb, as a dummy load to see what kind of current this thing can put out. So it's rated at 1 amp, so let's just try slowly dialing this in. Oh, here we go. This is a fairly low resistance load, so it's about 200 milliamps on the meter, and yeah, rough correlation. Try 400. Only running at 0.6 volts. 600. And oh, where you get some action, light bulb action at 1 amp. That's just, I'm just going to quickly full scale it, let's see what kind of current. Oh, it looks like it has a cutout. So if you turn up the current too far, it will actually just cut the power. Good to know. I'm just going to reach behind and see if the transistors... Whoa, wow. Yeah. The heat sinking on this, it's not good. That transistor is toasty. So I can't find my thermocouple, but I've left this running for a little bit at 0.5 amp, and even this, I can't even keep my finger on that transistor. I would not recommend pushing this little unit too hard. Of course, I'm dropping pretty much all of its voltages at heat in this configuration. So I might try to find a better matched load, see how it compares. So what I've got here instead is this little array of red, green, blue, white LEDs. These should drop about 0.5 amp at 12 volts, so should be a better matched load to test this power supply. Let's dial up the voltage. Red one lights first. Oh, that's pretty bright. 8 volts, 9 volts, 10, 11. Alright, let it sit about 12 volts. Drawing 430-ish milliamps. I'll just move this off frame, so... Okay. Alright, so I'll let this sit for a while, and... temperature of the transistor on the back is the point where it would probably be okay to leave this running indefinitely. It's hot to the touch, but probably less than about 80 degrees. Alright, let's have a look at the noise. I've got my scope set to 5 millivolts peak to peak. Let's plug it in. Alright, and we'll turn it on. Okay, so it looks like there's about 2 divisions or 10 millivolts of noise on the output under no load conditions. And it doesn't seem to change as you change the output voltage. Pretty typical for a linear reg. Alright, let's try it with a load. Okay, so it wouldn't really be very fair to use the LEDs as a load because they themselves have a very noisy switching regulator on board, so I'll have to use the light bulb again. Looks like there's a bit of fluctuation on power up. Oh, just in general, actually. Oh, I think that's just from me touching the terminals. Try that again. That's alright. Pulling about 0.5 amp. Yeah. The peak to peak noise is about the same. Average noise gets a little worse. All in all, it's not that bad for $35 anyway. Anyway, thank you for watching, and I will see you next time.